The next method to find limits is using the expansions of different functions. So, a mathematician named Taylor has given a general formula to expand any differentiable function f of x in terms of raising powers of x. That is, any function f of x can be written as f of 0 plus f dash of 0 into x by 1 factorial plus f double dash of 0 into x square by 2 factorial plus f triple dash of 0 into x cube by 3 factorial, so on up to infinity. So, if a function has to be expanded using Taylor's expansion, it has to be continuously differentiable. That is, all the infinite differentiations have to be possible. So, if that is so, every differentiable function f of x can be expressed as a polynomial. So, the derivation of this formula is beyond the scope of this course. So, you take this as the general formula, and using this formula you can expand many of the functions that you encounter in your 11th and 12th classes. So, fx is equal to f of 0 plus f dash of 0 times x by 1 factorial plus f double dash of 0 times x square by 2 factorial plus f triple dash of 0 into x cube by 3 factorial, so. So, we will use the formula for expansion of exponential functions first. So, the first type of function that we are going to look at is exponential functions. There are 4 types of expansions here: e to the x, e to the power minus x, a to the power x, a to the power minus x. So, e to the power x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, so on. So, I would very much encourage you to use this formula and see that you are getting this expansion. It's not very difficult. You just need to know the differentiation of e power x. So, e power minus x is 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 2 factorial, 3 factorial, so on. So, you get an alternate plus minus signs. So, if you have already not studied the differentiation, so you can try to derive these formulas after you understand differentiation. So, if you don't know the differentiation right now, you need to remember these formulas. So, even if you know the differentiation, so you derive this, and again you have to remember these formulas. So, you are expected to have this in your mind. You have to remember this. So, a power x can be written as e power x ln a. So, in the place of x, just need to put x ln a in this expansion. And similarly with e power minus x. A power minus x is e power minus x ln a. You get alternate plus minus signs. So, e power x, e to the power minus x. A power x, a to the power minus x. So, in e power x, all positive signs. In e power minus x, alternate plus minus signs. A to the x, all positive signs. A power minus x, alternate plus minus signs. So, once you have understood the expansion of exponential functions, it is next going to logarithmic functions, trigonometric functions, inverse trigonometric functions, and algebraic functions. The next type of expansion is the expansion of logarithmic functions. So, log 1 plus x to the base e, or log 1 minus x to the base e. So, log 1 plus x to the base e is x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 plus minus so on. So, the difference between exponential and logarithmic expansions is that there are no factorials here. These are just 2, 3, 4, 5, so on. And you have an alternate plus minus sign in log of 1 plus x. And log 1 minus x, you just need to put minus x in the place of x. So, if you put minus x in the place of x, this becomes minus x. Minus of minus x whole square is same as x square. So, you have minus x square, minus x cube, minus x power 4, so on. All the terms will be negatives. So, if you take a minus common, so you get x plus x square by 2 plus x cube by 3 plus x to the power 4 by 4 plus so on. So, in 1 plus x, you have alternate plus minus sign. In 1 minus x, you have all negative signs. Or if you take a negative outside, you have all positive signs. So these are the two expansions corresponding to logarithmic functions. So next you have trigonometric expansions. That is the expansion of sin x, cos x and tan x. So sin x is x minus x cubed by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial. That is, you have the odd terms of e power x. So in e power x you have all the terms 1 plus x by 1 factorial, x square by 2 factorial, x cubed by 3 factorial and so on. In sin x, you have only the odd powers of x, but with a alternate plus minus sign. And in the expansion of cos x, we have all the even terms, that is 1, x square, x to the power 4, x to the power 6, so on, again with alternate plus minus signs. So there is a pattern in the expansion of sin x and cos x. Sin x contains all the odd powers, cos x contains all the even powers of x. Next, we have tan x. Tan x is plus x cubed by 3 plus 2 by 15 x power 5 plus so on. So there is no pattern, there is no particular pattern in the expansion of tan x, but you just need to remember the first 3 terms. So first 3 terms will be useful in the problems. The next terms are not very useful. So x plus x cubed by 3 plus 2 by 15 x to the power 5. So you need to remember each of these coefficients. That is, the coefficient of x cube is 1/3. The coefficient of x power 5 is 2 by 15. And the next coefficient I also don't know, because it is not important, because as you know, if you are familiar with differentiation, the differentiation of tan x gets complicated in each step. The sin x and cos x, the differentiation do not get complicated. But for tan x, the first differentiation is secant square x. The next differentiation becomes more complicated. The next becomes still more complicated. So these are the 3 trigonometric expansions which you need to remember. So next you have the expansions of inverse trigonometric functions. Sin inverse x, the expansion is x plus half times x cubed by 3 plus half times 3 by 4. There is 1 into 3 in the numerator, 2 into 4 in the denominator, times x 5 by 5. Next, in the numerator you have 1 into 3 into 5, in the denominator 2 into 4 into 6, times x power 7 by 7 plus so on. So sin inverse x is x plus half times x cubed by 3 plus half into 3/4 times x power 5 by 5 plus half into 3/4 into 5 6 into x power 7 by 7, so on. And tan inverse x is equal to x minus x cubed by 3 plus x power 5 by 5, so on. So these are the expansions of sin inverse x and tan inverse x. So other expansions are not required for you. So these are the 2 expansions which will be required of you. So the last expansion that you are going to need is the algebraic expansion or the binomial expansion. So if you have the expression 1 plus x whole power n, so the answer is 1 plus nx plus n into n minus 1 by 2 factorial times x square plus n into n minus 1 into n minus 2 by 3 factorial times x cube plus so on. So 1 plus x whole power n will be equal to, so this is the expansion for 1 plus x whole power n. And this expansion is valid for natural numbers, negative integers and rational numbers. So this expansion is valid for positive natural numbers, negative integers or rational numbers. So this is valid for all the possible values of n. So this expansion will not be valid for irrational values of n. And one more thing that you need to understand or keep in mind here is that this expansion is valid only if x is in between -1 and +1. The expansion is valid only when the value of x is in between -1 and +1. And same is the case with the expansions of log 1 plus x and log 1 minus x. We have already seen what the expansions are. So these expansions which we have written will be valid only if x is in between -1 and +1. And in the case x is equal to 1, so this in the limiting value tends to this value. There is 1 plus nx plus this so on. As x goes closer and closer to 1, this expansion tends to 2 to the power m. So you need to understand these special conditions where the formulas can be applied. So these are the 5 standard types of expansions which you need to keep in mind, and these will be useful in solving certain types of questions in limits. So let us look at some sample questions where expansions will be useful.